You already have a coordinate there, but I guess that's fine. Draw it however you get there. So the question would be, if you're supposed to give the perimeter of this rectangle, how do you figure out what the lengths of the sides are? Okay, you're only given these coordinates. You know it slices through the squares, but how long is it from here to here? Anybody? I don't know. 3. Now, unfortunately, in math, you can't just guess, and it's not 3, but that's a good try. Lauren? Yeah, you're probably, because these things are drawn on slants, you're probably going to have to come up with a different way, and the best way we know how right now is to use the Pythagorean Theorem. Now, the question would be, how can I make right triangles to find that? John?
Split the rectangle in the middle. Whatever.
I mean, like do this?
Yeah.
Well, the only problem with that is, if I split it like that, I still don't know this side or that side or any side to figure out what that is. It's a good thought, but that's not exactly it, but we can still do it, Lucas?
Why wouldn't you just rotate it?
Because when you rotate it, it's not going to end up. How are you going to do that? Okay, go ahead, rotate it for me.
So, I can't use my mind.
I'm going to tell you when you do rotate it, it's going to end up coming somewhere up here, and it isn't going to be an exact thing on those things there. So you've got to come up with another way. Be a problem solver, Nick Shanks.
You draw triangles off the sides. Like
Alright, I think this is what Nick is saying. You can make a right triangle here, make this triangle, this is the hypotenuse with those two sides there. See what we're saying? Okay, that is the hypotenuse with those two sides there. So, I can figure out what the distance is from here to here. How tall is this from here? It's 1, 2, 3 exact. How tall is it from here to here? 3 exact. Okay, so my Pythagorean theorem says, do we have a 3-3 triangle? No. A squared plus b squared equals c squared. 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. C squared equals 18.
The square root of 18.
So the c equals the square root of 18, which is almost correct, except for the fact of it can be simplified into what? Square root of 18 is the square root of 9 times the square root of 2. What's the square root of 9? So it's 3 times the square root of 2, which Nick Shanks is going to tell me something about, or John's going to tell me. Who's going to tell me that? Remember when you have we talked about this, an isosceles triangle, the hypotenuse is the square root of 2 times whatever the one side is. So here is 3 times the square root of 2. That is the length of the long side. Okay, now we just got to figure out the length of this other side here. You do the same thing. You make a right triangle from those sides, which is going to be what? Those sides are both 2. By the way, you could tell me what that side is. Anybody, what's that side? Hypotenuse would have to be 2 times the square root of 2. But you can still do it out like this. It would be 2 squared plus 2 squared equals c squared. 4 plus 4 equals c squared. C squared equals 8. C equals the square root of 8. 4 square root of 4 times the square root of 2 is 2 times the square root of 2. How many people are excited about that? Now, giving those two measurements, I can find both the perimeter and the area. How do you find perimeter? Add up all the sides. So I got 3 times the square root of 2 plus 3 times the square root of 2 plus 2 times the square root of 2, right? Plus 2 times the square root of 2. Can I add those together, ladies and gentlemen? Yes or no, Emma Kreis? Can I simplify that?
I think so.
She thinks so. What can you do?
Put the square roots together.
Am I going to get the square root of 8 then? let me throw this at you. 3 times the square root of 2 means that you have 3 square roots of 2 added together. 3 more plus 3 more square roots of 2. Plus 2 more square roots of 2. Plus 2 more square roots of 2. Which means I end up with a grand total of, how many square roots of 2, Laura? 10 square roots of 2. The square roots, when you add, it's just like these were x's. You have 3 square roots of 2 plus another 3 square roots of 2, that's 6 square roots of 2, plus another 2, that's 8 square roots of 2, plus another 2, that's 10 square roots of 2. That is the perimeter of that rectangle. Okay? Square roots of 2 don't change, you're just adding all those together. The area, on the other hand, is length times width. So there you're going to have 3 times the square root of 2 times 2 times the square root of 2. Somebody want to walk me through what's going to happen on that? Well, we already talked about it. You know, if you have square root of 2 times the square root of 2 is what? 2. Just a normal 2. So now I have a normal 2 times another normal 2 times a normal 3. So the area actually ends up being 12 square units. Which, believe it or not, we could actually count on this thing here. Check this out. The magic of mathematics here. Let's count out the squares. What color shall we use? A little pink. Here's 1 whole square, 2 squares, 3 squares, 4 whole squares, 5 whole squares, 6 whole squares, 7 whole squares. Put these two, these are both half a square, so you put those together, that would be 8. Those 2 halves together, that would be 9. These 2 halves together would be 10. These 2 halves together would be 11. And then this little half here would go with that opposite half there to give you the 12th one. There's your 12 square units, just like government. Lauren?
Do you accept that? We just had it.
No. If you were in 1st grade and taught baby talk, oh, I didn't want that. I wanted to zoom back. Room full? There we go. Let's try the next thing here. Here, use the Pythagorean Theorem to find the length of the rectangle. Oh, sorry. That was the one we just did. Hi, sorry. How about this one here? Refer to the illustrated right triangle to find the length of the hypotenuse and the perimeter of the triangle. How long, I'll give you a second, let you figure that out. How long is the hypotenuse here? How long will that hypotenuse be? If one side is 1, the other side is the square root of 3, how long is the hypotenuse using the Pythagorean Theorem, which is right here? Do you have an answer for me, Jackson? You have to actually write something out, believe it or not. This one is definitely not, I can do this in my head kind of stuff. Well, you might be able to. There's an outside chance you could. And you would be outside if you were doing it. Jack, did you write it down? Give me what you think the answer to that would be. So you look awful smart when you start using square roots of things. Let me give you a jumping off point. A squared plus b squared equals c squared. Pythagorean theorem, people. You can get nowhere without that on this. Fill in the blanks. Fill in the proverbial blanks there, kids. And give me the perimeter too. Did you do all of it? And give me the perimeter. Love this. If I only had a parade.
Remember last year when you showed that?
I did, and he said it wrong,
I know.
unfortunately. Lucas, did you come up with something for the hypotenuse? What is it?
Square root of 3.
Lucas says the square root of 3, which I'm going to doubt because it would not be the same as this length here. Let me look at it here, Lucas. What'd you put for a squared?
Square root of 3.
So square root of 3 squared plus you must have used 1 for b squared, and that equals c squared. Alright, square root of 3 times the square root of 3 is?
3.
1 times 1 is?
1.
3 plus 1 is? If c squared equals 4, c equals the square root of 4, so c would have to equal 2. I didn't either. So that was your hypotenuse, and then the perimeter would just be 1 plus 2 plus the square root of 3. Well, 1 plus 2 you can put together, but you cannot add the square root of 3 to that. They're not like terms. This is as much as you can do. The perimeter is 3 plus the square root of 3. But again, in your mind, children, you should know what the square root of 3 is. We knew the square root of 2 was 1.414, right? Square root of 3 was what? 1.7? Lauren? Did you ever say the square root of 3? Don't worry, I can find it. Square root of 3, children, is 1.73. 1.73. So if I asked you what this would be close to, you would say it's 3 plus 1.73 is about 4.73. Almost 5.
Well, how would you find that out with that?
Yeah, that one you have memorized. The only other way, by the way, there is some way to do square roots that I don't remember. So you could do trial and error. 1.5 times 1.5 is what? 25 times 25 is, right?
25,
Well, you can do 3.
25 times.
What is 25 times 25 is what?
25 times 25 is 125.
525. I don't know if that helps. What does that help? I say 1.5 times 1.5. 225. So you got no choice in that. Forging ahead, children. Here we go. Let's see. Oh. Want to do this one? Let's do this one.
Yeah.
We didn't do that one. Thanks for asking. Who asked? What?
That's good. You know, it's just probably recording.
Things were so much quieter when John wasn't here.
It works.
You're welcome.
There you go. Here's the deal I'll make with you. If more than half of you get it right, I'll only give you half of today's assignment. So focus. More than half. That means there are exactly 16 of you. 9 people in here. Wait, what was the actual question? What is the perimeter and the area? I'll just do one. I'll do the perimeter.
Except can't just comment.
You get me, half of you get me the perimeter right. We'll just do half. A lot of pressure here. Done exactly the same way we just did that problem not very long ago. I wonder if that is a, just to pique your interest there, Jack, that's, I believe the triangles you make are 30, 60, 90s. Perimeter. You're supposed to do both, but we'll do perimeter for all the, let's make a deal behind door number 1, door number 2, door number 3. No cheating, Christ. I see what you're trying to do back there. Lawrence, you got it? Wow. Jack, you got it? When you finish, circle your answer, and I want to just take a quick peek. Where's your answer? Huh? Got an answer? Sorry, Bill. Just yet, but I know we're getting there. Answer? No, it's
Just kind of squares.
That's the perimeter? Where's the perimeter?
Where's your perimeter? It's right there.
Huh? That area, perimeter. Points at the right place. But you can't, kids, you can't draw this thing and just put points anywhere, because you're making triangles. You got an answer? I don't know.
If you add 4 to 5, it's 5
You don't you dare. Tell people to do twice.
No, don't take it.
Jack, your answer is? Again, I find it hard to believe you can, that you wouldn't even at least write the Pythagorean Theorem down somewhere, because there's not a lot of effort on the extra mile. Yeah,
Well, they gave me a logical answer. He explained it.
Is that 50? 5. All right, kids, take a look up here. Yeah, well, we don't have that yet. Okay, the only way to find how long each side is to make right triangles. Unfortunately for you, every one of these triangles is the same, so you only have to do this once. So your Pythagorean theorem, this triangle is 2 wide by 1 high. So if you do a squared plus b squared equals c squared, it is 2 squared plus 1 squared equals c squared. So it's 4 plus 1 equals c squared. 5 equals c squared. C equals the square root of 5. And the square root of 5 cannot be simplified. So every side is the square root of 5. And if you're finding perimeter and adding the square root of 5 plus the square root of 5 plus the square root of 5 plus the square root of 5, you end up with 4 square roots of 5.
20.
Okay, you can't add, you don't do anything with the radicals. Now if I asked you for the area at my price, it would be area would equal the square root of 5 times the square root of 5, which is the,
See, we should have done that one.
which if you look at it, that very well could be, because you could take this is 1, add those two together, it's 2, 3, 4, and 5. How many people had 4 times the square root of 5 without looking at their neighbors?
Yeah.
Left it as a square root of 5, it's a square root of 5, it's a square root of 5.
Well, it wouldn't be simplified there.
Yes, it would.
And for those of you that didn't get it, tell me why, because most of you I walked by and I didn't even see this written down, and I don't know how you could try to do it without writing down the Pythagorean theorem, because that's the way we did it before. It's no different than the other one we did. By the way, I don't think this is the 30, 60, 90 triangle, because I think this was 1, that was 2, that was like the square root of 3, was it? Something like that. Alright. Is this thing stuck?
It's
You're on
frozen.
freeze.
Oh. Oh. Oh.